Agreed? Okay. So now we can do it for any time we need to.
And what do you use that for again?
You'll see in the next section, more than this section.
No, but like, how would you you would use this? You said like if n was 1,000.
Yeah. If I said,
or is it just like large n value?
Any n value. If I said add the first three numbers, so you can say 1, 2, and 3. That's 6. 1 plus 2 plus 3 is 6. Or I could say 3 plus 4 is 12. Divided by 2 is 6. Right? It's when you get into larger numbers, this formula is more relevant because I can't add up 1 through 1,000, 1 through 1,000,000 that quickly in my head. So the logic behind this formula, if you just think about it very quickly, if you had 1 and you want to add to it 2, or I'll just write the numbers themselves, 3, 4, I don't know, however far you want to go, until n minus 2, n minus 1, up until n, right? Until that last number you want to add up. So if you pair these numbers off, it's a good way to think about adding. If you pair these numbers off here, n and 1, you add them together, right? What will you get?
1.
You're going to get n plus 1. Right? You take the last number and the first number, add them together, you're going to get n plus 1. In other words, you're adding numbers 1 through 10, and you take the last two, and you pair them off, you will get 11. You get n plus 1. N is 10, you get 11. Now as you pair the next two down, you're going to get 11. The next two down, you're going to get 11. And 11, and 11. How many 11s do you get?
5.
5. Half of that number, right? That's what this is saying. This is saying, it's really saying n on 2, take half of n plus 1, right?
So if we took this one, we would put, so 10 is n, so it would be 10 times 10 plus 1, which is 10 times 11 over 2.
That's right, 110 divided by 2. 55, that's right.
Okay.
That's right.
Okay.
That's the logic of why this actually works. So 2 plus n minus 1 is also n plus 1. But that's going to happen how many times? You now paired them all off. If you've paired them all off, you have half the numbers you were adding together a minute ago. You have half of them, right? That's what you have. You have half of how many things you're adding together of what objects? Of the number n plus 1, whatever n was. So that's why the formula works. All right. Now what happens if I ask you a more complicated question? It is truly more complicated. I ask you to take the first, who knows how many squares, and add them together. So I want to know what 1 squared plus 2 squared plus 3 squared plus 4 squared is. I want to add those things together. That's what we do. Right? Squaring process going in between each and every summand. So I'll just give you the formula. We won't derive it. It'd be too painful. Oh, goodness, I remember it. It is n. Yeah, I forgot it actually. It's n plus 1, 2n plus 6 plus 1. I'm not so confident about that. Anybody remember this formula?
What is it called? We can look
Is that
up.
right? It's right. That's right. I haven't seen it in a while. I don't remember. Thanks, what it is. It's ready. You sure?
Yeah.
Maybe you want to check the book.
Oh wait, no, I have it.
You don't.
I swear to God, I have it. Yeah.
Oh, it is right. I have it. Thank you, Sredi. Good deal. All right. So again, if you want to add up 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, we're going to want to very shortly.
Oh yeah, I got it.
You got it? n plus 1, 2 plus 1 and 6?
Yeah.
It is right. You and Sredi agree, and the book agrees. So
I agree.
I should probably stick with this. All right. So there's our formula. And we'll go up one more power, the sum of the first n cubes. 1 cubed plus 2 cubed plus 3 cubed, as far as you want to go. It is. This is the first equation squared. That's right. It's remarkable. It's remarkable that is the case. So I had to remark. I don't really know what to say about it, though. It's so strange that should be true. First one squared. That's an amazing fact. All right, so let's take a quick example. Justin here, he likes these examples. So here we go. I equals 1, 2, times 125, I cubed. I want to add up 1 cubed plus 2 cubed plus 3 cubed all the way up to 25 cubed. I want to add all those together. That's getting pretty big. 25 cubed is already what?
That's a big number.
That's 25 squared times 5. You gotta put one more 5 on there.
151,000.
Not too big. 15.
You said another 5.
Another 5, not another 50. You said 3,000 a second ago.
Oh, I mean,
You said 25 cubed.
15,125.
No, 15,600.
There you go. So you're getting pretty big numbers already. You're only on to 25 because all cubes pretty large. But I'm just going to follow the formula. All I got to do is take 25 times 26 divided by 2 and square that result. So now, again, you're always going to have an even in here, so divide it out initially. So 26 divided by 2 is 13. So 25 times 13, since you guys know about quarters and dollars, you'll figure that pretty easily. What's that? $3.25, right? Okay. We're going to square that result though. So we have 325 quantity squared. That's a pretty big square to handle, but still better than what we would have had to do otherwise. So I'm not afraid of doing donkey work here. What is it? 5,600. Okay, say so. And there will be our result. That's the sum of the first 25 cubes. There are properties this summation notation has. This is formula. This is specific formulas, but there's also properties. We'll write them out now. They are also going to be very useful to us, especially in the next section. But they introduce all this notation here. All these properties are based on the fact that single notation means to add. Okay? So, should you have C, I'm going to use AN. I think it's the text for 1 second. This is N, are you kidding me? I'm gonna write slightly differently. AN is some function of N. Okay, N is some function of N. So, just as a quick example, for introducing properties, you could have something like 5 times N squared, N equals 1 to 45. So here I'd be claiming that AN is the function square, the squaring function happening to N, right? You compare it with this. So AN is some function of N, okay? In this example, N squared. And then 5 is this constant, C, 5 is the 5 in this particular example, okay? C, which is a constant, is 5 in our example. Good. So what the rule is, if you just think about it for a quick moment, what does this say? This would say 5 times 1